Hi, today I will be showing how to program the microcontroller STM32F103 to use the ultrasonic sensor. The way the ultrasonic sensor works is by sending a sound wave using the trigger pin and receiving the sound wave using the echo pin. And the distance is calculated by how long the sound wave took to go from the trigger pin to the echo pin. The pins are connected like this. We have the 5 volts and the ground, and the trigger is connected to the port B pin number 3, and the echo is connected to the port B pin 12 in the previous video. So here I have the delay function that is implemented using timers. After this, I have the alternate function that disables the JTAG configuration for the port B3 to act as a general purpose. Next, we configure the port B3 to act as an output port. All of this configuration I explained in the previous video. So what is new in this one is that we are configuring the port B12 that will be used as the echo functionality for the sensor, and the port B3 will be used as the trigger. The trigger is the one that will send data, the trigger is the one that will send pulses, and the echo is the one that will receive this pulse. So because of this, the PB3 needs to be as output and the PB12 needs to be as input. If we go to the documentation, the PB12 is located in the CRH registers, and since this port needs to act as an input, in the mode we set the value 00, and for the mode we have here the input section we can use as the float input. So back in the code, here we are resetting all the 4 bits from 16 to 19. In the mode we need to choose the input mode, which is 00, but since we are resetting, we already have 00, so there is no need to set again. And the configuration, we need to set the float mode. In the configuration, we need to set the float input, and here we are setting. And after this, we enable the peripheral clock of the timer. Next, we can start configuring the sensor. If we go to the sensor documentation, we can scroll down, and here we have some important information. So first of all, it needs to be attached to 5 volts. So here we have the trigger pin that is responsible for sending the ultrasonic burst, and it should be set to high for 10 microseconds. When it happens, it will send an 8-cycle sonic burst at 40 kilohertz. After this, the echo pin will go high. So back in the code, let's implement that part. Here is the piece of code that we need for that part. We enable the trigger, we set it to high, then we can use the delay function to wait 10 milliseconds, and after this we can disable the trigger. This line of code means that by the time the trigger sends a burst, the echo pin goes high. While the echo pin is high, means that the trigger is sending a burst. So we also need to check whether that burst has finished or not. So to do this, we can use the opposite. We can check whether the IDR register is low or not. If it is low, means that the trigger has finished sending the burst. Here in the delay function, as I explained it in the previous video, we are using the prescaler as 8000 because we want to count in milliseconds. If we go to the sensor's documentation, the distance is given using microseconds. So we need to verify this. So instead of using milliseconds, let's use the counter to measure in microseconds. So instead of using the prescaler 8000, we can use the value 8. And why we use the value 8? If we open the calculator, we can see that we have 8 megahertz. So if we divide this 8 megahertz by 8, we have 1 megahertz. In 1 second, we have 1 microsecond. Since we are using the same timer as we are using in the delay function, let's reset the timer, set it to 0, and between these two checks, we can start the timer. It needs to be before this checking, because by the time we pass this check, all the burst was received. So when we get out of this loop, it means that the timer will have the value that the burst took from trigger to the echo. Now we can start calculating. Let's save the value that is in the timer true, will be the duration in microseconds. Now the formula, if we go to the documentation, to get the distance, we need to multiply the time, which we already have using the timer, and also we need to multiply by the speed of the sound, which is 343 meters per second, divided by 2. So back the code. Here we have the distance, which is the duration, which we can get from the timer, and we multiply by the speed of sound and divide by 2. But here's the thing. The duration is in microseconds, and this value 343 is in meters per second, so we need to convert this. So first, let's convert to centimeter, which is the value. Now we can convert to microseconds, which will be this value. But one thing about the microcontroller that I'm using, which is the STM32F103, it does not have a FPU, the floating point unit. So it means that we cannot perform floating point values. So this line would give an error. So what we can do is to keep the value as it was, but here instead of dividing by 2, we can compensate, divide by the same amount of decimal place. So with this we get an approximate value, because we are not using the floating point to be more precise, but it's still working. Now that we have the distance, we can use this to perform some operations. Now let's see in the analyzer the behavior of this. The white line is the trigger, and the orange line says how near or far I am from the sensor. So if I start getting closer to the sensor, the line starts getting smaller. If I start walking away, the lines start getting larger again.